Last week, you were looking at the bell curve. So the middle of that bell curve is your average, right? And then we broke it up into standard deviations. This was 1 standard deviation above, 2 standard deviations above, 3 above, -1, -2, and -3. So we had a percentage breakdown, and the percentage was given to you. So 68% of your data fell between +1 and -1 standard deviation, right? So if it asked you, the questions should have been like, they would give you the average, they give you the standard deviation, said what percentage of the scores fell in this range. Well, that's fine and dandy as long as my score is based on an exact value of the standard deviation. Okay? What happens if the score, I want to find out what percent it is, if the score is in a range, say, right here, plus 0.5 standard deviation. That's what we're going to find out today. Now, these right here, we call them standard deviations, but they're actually called z-scores. All right? So z-scores work like this. A standard normal distribution has a mean of 0 and a standard deviation of 1. A z-score is a standardized value that indicates the number of standard deviations the data value is above or below the mean. So a z-score is found by taking your score. Now this is a new symbol, but it means average. Okay? So that's a new symbol to you. And then we divide it by our standard deviation. Okay? So this z-score allows us to find out what percentage of scores fall above or below that actual score. Okay? Z-scores can be used to compare different sets of data that do not have the same mean and or standard deviation. A positive z-score indicates a data point above the mean. A negative z-score indicates a data point below the mean. All right. Now, as well, we are going to use there's a table in the back of the book that we have to look at. So this is on page 294 and 295. And if you have a look at that table in the back, my average here. That table in the back gives you the scores that are below, as a percentage, are below the actual z-score that I have. Okay, so everything is to the left. So if I have an actual z-score of like -1.25, I can look that up on the chart and it'll tell me what percentage falls below -1.25. So if you look along the left margin, let's use this as just an example. So the left margin, you find -1.2. Okay, does everybody see -1.2? Then you go across to 0.05. And what percent of the scores fall below -1.25 standard deviation?
0.1056.
Yeah, and that actually is a percentage of 10.56%. So then the question could say, okay, so what percent of the scores is greater than that value? So how would I find out what the percent of the scores is that's greater than that value?
89, subtract that from 100.
Subtract that from 100, right? Or if you're using your chart, you just subtract it from 1. Okay? It's not real difficult to do what we're doing, as long as you already have the normal distribution stuff nailed down. Okay? So let's have a look at your example question, and then we'll use this again. A mathematics test score in Ramon's class are normally distributed. The mean is 80 with a standard deviation of 5. Callie is in Ramon's class. She scored 83 on the test. Compare her score with the rest of the class scores. Okay, so one thing that you get used to is when we compare actual scores, for example, test scores, You can use a number of different ways in order to compare it. This is one of them. Another one is percentile rank. We don't do that yet, but you do percentile rank. So that compares you to everybody else in your class. Okay? So in this case, we're going to find out what percentage of the scores fell below this girl's test score. So the first thing I do is find out what the Z score is, the standard deviation score. So I do that by taking her score minus the average score and dividing it by the standard deviation. So 0.6. So now let's go to the chart then at the back of the book and let's find 0.60. And what percent of the scores fall below her score of 83?
74%. 0.7.
So the percent of the scores, so 72.57% of the scores in that class, in Ramon's class, scored less than her score of 83%. Does everybody know how to find 0.6 there? Just find it on the left margin and then go over to whatever the hundredths value is. So in this case, you're at 0.6 right here, and you go, right there, and then you go across to 0, because it's 0.60, and so it gives you 0.7257.
Oh, so if it's 0.62, you go
You
0.6.
keep going to point, you keep going over, yeah.
Okay.
Okay? So we had it on the chart. Not a lot to it, is there? And again, what we'll do maybe tomorrow is we'll get the calculators out, and there's ways in which we can find all this stuff out on the calculators as well. Okay. Mean lifespan of a non-stick frying pan is 2 years, with a standard deviation of 0.5 years. Carney is an avid cook and wants to replace her frying pan after 65% of its natural life. When should she replace the frying pan? Assume the lifespans of this type of frying pan are normally distributed. Okay, so we're going to work this Z score backwards now. All right, so we've got Z equals her score minus the average over standard deviation. And she wants to replace it after 65%, right? So she wants it to last 65%. So-
0.065.
So that's 0.65, but I have to go into my book now, into my chart, and I have to find the number that's closest to 0.65, the Z score closest to 0.65.
Wouldn't it be 0.065?
No, 0.65,
Oh, that would be 6%.
right. Okay, so find 0.65. What number is closest to 0.65? So you're working the chart backwards now. Yeah.
Maybe
So remember, you're given a percentage. You're trying to find the Z score. So what would the Z score be, approximately?
0.309 or 0.39.
0.39? Yes, no? Okay, so what's 0.39? What percentage is 0.39 on here?
65.2.
65.17, right? And what's 0.8? What's 0.38?
64.8.
Okay, so who's lost? There's no. Okay,
Yeah.
so I'm looking across this chart to find the closest number to 65% as a decimal. So that's
All these
0.65. Yeah. So I find it up right here. Right there.
Oh, I see. You just gotta find which one.
Yeah, and so now I want to work my Z score back. So it's probably between 0.38 and 0.39. Would we agree?
Yeah.
That's the closest to 65%. So what they did in the book is they actually did this. They said 0.385 is the Z score,
Oh.
okay? And then I've got X, subtract, and what's the mean life? 2 years, correct? And what's the standard deviation? 0.5. So now I've got to find out how many years that's going to be.
What's the standard deviation?
It's given to you in the question. Okay, so now 0.385 times 0.5 and then add 2. So I multiply that up to here and then I add 2 to it, and x equals 2.1925 years. So the question said, if she's going to replace her frying pan after 65% of the use, she's got to replace it in 2.1925 years in order for that to use 65% of the use. Okay? All right? So when you look at the Z-scores are the columns and the rows, right? And then there's percentages. So that's what's the percentage of it happening to the left of it that's greater than it. So it's always working to the left off that chart. Fair enough? All right. I missed Friday with you. Was there questions from, or Thursday, sorry? Questions from 5.3 and 5.4 that you want to look at today? Anybody today?
For like number 4, he's trying to find the average.
What page?
125.
Number 4 says find the average, yeah?
If you set up an interval or whatever, don't
Yeah.
you do like f times x?
Yeah.
Gets you your number and then divide it by
Yeah, and then you divide it by the total number.
of x.
Yeah.
When I did that,
Well, you divide it by this total right here.
but I'm not total was 24.
Okay, so when you're doing the intervals, you may not have as accurate answer as what they do in the book, because you might have changed your intervals differently. Okay, so their intervals might be a different, and so that when you do the f times x times your midpoint, that could change the answer a little bit. So if you are off by a little bit, then you're doing it right. Okay? Ideally, when you're doing these questions, if I was to find the average looking at that set of data right there, I would do it for each individual one. Just to find the average. And then I would do my interval after. Okay? You understand what I'm saying?
Yeah.
All right, and then that way it's accurate. But like I said, there is a way to do this calculator-wise. Okay, are there any other questions from 5.3 and 5.4? So we're looking now, we're all done 5.4? Okay, that's fine. Okay, so work on 5.4 and 5.5 today then.